Hi everybody, this is Arnaldo Castellucci. I'm an endodontist in Florence, Italy with a limited practice to end of more than 43 years ago. I'm happy to show you how it works, the very last generation, the third generation of Apex Locator, the Apex made by Woodpecker, China, and it works as an Apex Locator and also as an electric pulp tester. Is very reliable, and I'm going to show you a video on how it works and how to interpret the sign you can read on the scale. Thank you. Let's first discuss the use of the new third generation Apex Locator, the Apex. This is based on a new, completely revolutionary electronic system. It's influenced by the thickness of dentin around the tip of the instrument. The thickness of dentin in the root canal is the same until the most apical 4 millimeters when it decreases. Dentin is an excellent thermal and electrical isolator, so when a file is inserted into the root canal and sparks an electronic signal, the signal will try to pass through the dentin and reach the periodontal ligament and bone. As the instrument penetrates deeper inside the root canal, the thickness of dentin reduces, and this allows more electronic signal to pass through and reach the device, which informs the dentist that the instrument is closer to the end of the canal. At the final part of any dentin wall, the foramen equator, the thickness of dentin and impedance will be almost zero because there is little isolation. This is why the 0 point is the most accurate measuring point, as it is the most apical part of the root canal. The most critical part of the K-file is its tip, which must be in contact with the dentin. This explains why sometimes the signal is not stable on the device reading, because the instrument is too thin and is losing contact with the dentin wall. To have a reliable reading, the reading must be stable. When the file arrives at the foramen equator, it will not have any more dentin around. The reading of the Apex Locator corresponds to 0, and as I already told you, this is the ideal situation represented by a root canal, which becomes narrower and narrower to the end, which means we are at the foramen equator. So this is the 0 reading that we are looking for, which means we are not more surrounded by the dentin. The tip of the instrument is exactly at the foramen equator. In other words, like any other Apex Locator, the number 0.5 or 1.0, they are not millimeters. So, like any other Apex Locator, the Apex is not telling you when you are 0.5 millimeter from the apical foramen. It's telling you that you are closer and closer, but you have to arrive to the 0 reading, which is the foramen. Then, if you want to stay shorter, half or 1 millimeter, you have to measure on the scale and shorten your working length. Let's see now the typical example when the use of a narrow instrument inside the root canal is giving you not a stable reading. As you see, the scale is going up and down. You are already out when you see the red bars, and you move it just a little to stay shorter, and the scale disappears. So, which means that the instrument is too narrow. Let's start using a bigger instrument, number 10, for instance. And it does exactly the same. The instrument is not making good contact with the dentin, and the reading is not stable. Let's go to the next size, the number 15. The number 15 very slowly is reaching the foramen closer and closer like now. Now we are too long. Go back. Too much. Too long. Back to the stable reading at 0, 0. Now this is the stable reading. This is the exact working length. So we reproduce we on the scale the working length. We reproduce the same working length of the bigger instrument, the size 20. Let's confirm the working length. As I already told you, you want to have a stable reading at 0, 0. Okay, closer and closer. Here you are. The instrument is exactly the foramen with the size 20. Let's try now with the bigger size, the size 25, at the same working length. Slowly, the instrument goes to the same working length, gives you a very stable reading and very, very reliable, very precise. As we know, the reading is more precise and more reliable the more the size of the instrument is close to the size of the foramen. And these are the images of the same instrument, the 25K file, as seen at the microscope. And medium magnification, higher magnification, here about 12 magnifications. This is about 15 magnifications. And this is the maximum magnification, at about 20 magnification. And you see the instrument is exactly at the foramen. I hope you enjoyed the lecture, the presentation, and please, if you have any question and you want to have my answer, don't hesitate, send me an email and I will answer to you as soon as possible. Thank you for your kind attention.